Something else that we looked at back in chapter 2 was this idea of taking a basic graph and then applying a transformation, either shifting it left, right, up or down, reflecting it over the y-axis or the x-axis. Even we could multiply by a coefficient out front and stretch it, or if we wanted to, we could compress it. We do that same thing with polynomials of higher degree. So let me give you an example of that. The example we'll go with here to begin is, let's look at a polynomial of third degree. So x cubed minus 9x squared plus 27x minus 27. That looks pretty complicated, and in that form, like it is there, there's not a lot we can tell about it. However, and we'll learn this later on in chapter 3, we'll learn some techniques for factoring these polynomials. If I tell you that this is actually just x minus 3 cubed, well, hopefully that gives you a sense of how it's so similar to x cubed, except it's x minus 3 cubed. If we look at the graph of x cubed, we know, we've seen it before, that looks like this. But if we're going to subtract 3 from every value of x that we put into this function, then what we saw before was if 3 is going to be removed, like if you apply a tax, if you know that every time you put something into this function, the first thing that's going to happen is 3 is going to be removed, then to compensate for that, we're going to have to increase our input by 3. So how this will be different when we graph x minus 3, if we graph x minus 3 cubed, instead of crossing through the origin, it's going to shift 3 units to the right, and this one's going to look like that. We're familiar with this. We've seen this type of transformation before when we've talked about quadratics back in chapter 2. Let's look at another function and figure out how it's been shifted with transformations. If we compare p of x equals x to the fourth to p of x equals x to the fourth plus 4. Okay, again, this should be familiar. When we looked at functions previously, we saw that we still have your basic x to the fourth. It's just that whatever the result is, we're going to add 4 to the output. So after the fact, after we've already figured out x to the fourth, we're going to add 4 to that. Now, if we think about x to the fourth is like x squared. So it's going to look like this. But if we're going to add 4 to every value of that, then it's just going to shift everything up by 4. And so it's going to look like this. If we take this up a notch and we, again, compare the function f of x equals x to the fourth to negative 2x to the fourth plus 4, okay? Same thing, we're going to add 4 at the end, so after the fact we're going to add 4, so that's still going to raise this up by 4 units, but 2, this is like the amplifier, this is that we saw back in chapter 2, we're going to be increasing, we're going to be doubling the output, and then we're going to negate that, so negative, okay, so what this looks like is, instead of, let me draw the function, the standard. If this is what x to the fourth looks like. Then we multiply it by 2, it's just going to increase, and it's going to double the output, so it's just going to be increasing faster. The negative is going to flip this thing around, so take this and reflect it over the y-axis, so it's going to look like that. But then remember this plus 4, that's going to shift this whole thing up 4 units. So in the end, it's going to look like this. Now I've made a royal mess of the board here. But hopefully, if we start with the original function x to the 4th, if we multiply it by 2, okay, and then we negate everything, so everything that was positive is now negative. So that's the third step. And then finally, if we add 4 to everything, it's going to shift it up 4 units. Hopefully that's familiar to what we've seen before.